So I'm going to do a quick video on the bell curve, and it's actually kind of neat. Um, there's a few things you need to know. X bar is the mean, and mu is the mean as well. A lot of, I'm going to explain this a little bit later, but this is for a sample population, and this is for the total population. Standard deviation, they usually use S or sometimes like S of X, and this is a lowercase sigma, and that's also standard deviation. And once again, this is for the samples, this is for your population. If you're in high school math, you probably don't need to know too much about the difference between sample and total populations, but you probably have an idea because, well, a good teacher should have told you. You will need to use this information at some point in time, but not for today's video. So what we're going to do is I'm actually going to look at the bell curve. What it says is X bar, and here's where my notation doesn't actually make a whole lot of sense, because you can see X bar is implying the sample, and I'm using sigma for my standard deviation. So once you can get around that, you should be okay. Actually, I had fixed it on my notes, but it's still here. So this should be a mu, because I'm using sigma. But once again, don't worry about that too much. Here's the key. This is my mean. All right. So this is one standard deviation above and one standard deviation below. This is one standard deviation above. This is one standard deviation below. And 34% of the data, about 34%, 34.1, will fall one standard deviation above and one standard deviation below. So if I gave a test and the scores were normally distributed and it had a mean of 80 and a standard deviation of 4 points, that would mean that 34% of the students would be at an 80 plus one standard deviation above, which is 84, which is right here. So 34% of my students should be one standard deviation above. Now, I don't know why I put a bar above the 80. That also means that 34% of my students should be one standard deviation below the mean, which would be a 76. If I want to go 2 standard deviations away, I would say 80 plus 2 standard deviations, and that would be, well, an 88. That means here is 2 standard deviations above the mean, and this would be an 88, right? So this would be an 80, this would be an 84, that looks like an 89, this would be an 84, this would be an 88, and this would be a 92. This would be a 76, this would be a 72, this would be a 68. So that's how it works. You can see 34% of my students got between a 76 and an 80. I think that's probably the best way to explain it. 34% of my students got between an 80 and an 84. Between an 84 and an 88, only 13.6% of the students received that score. And look at this, between an 88 and a 92, only 2.2%. So now I'm going to move on and say, all right, that means between a 76 and 84, these are all the students that are one standard deviation away. One standard deviation from the mean. That represents one standard deviation below and one standard deviation above. And we just said that that was between a 76 and an 84. That means about 76 to an 84. That means 68.2% of my students fell between a 76 and an 84. If I went 2 standard deviations from the mean, that would be, well, let's see, a 72 to an 88. It means 95% of my students should be between a 72 and a 78. And then 3 standard deviations from the mean. Now remember, 1, 2, 3. From the mean means here, the middle. 1, 2, 3. that would be a 68 to a 92. And the reason why is because each standard deviation for this example is 4 points. So here's my 80, 84, 88, 92, 80, 76, 72, 68, and 99.5. All of my students, in theory, should be between a 68 and a 92. Maybe there's one that's below a 68. Hopefully not. Maybe there's one above a 68. Wouldn't that be wonderful? And the very last thing I want to do is I want to do this, showing it cumulatively. 0.1% of all the students got less than, and for our example, I'll put in the numbers. 68, 76, 76, 80, 84, 88, and 92. 0.1% of all students should be less than a 68. 2.3% of the students should be less than 72, and so it would be like this amount. 15.9% of the students, so you can see it's cumulative from 0, right? And then half my students, so the 50th percentile is your mean, and that should make sense because it's in the middle. And another 34%, if you go back to graph 1, and that means from 0 to here is 84% of the students. Oddly enough, if I said what percent of the students scored an 84, it should be 84%, and that's coincidence. If we did all the way from 0 to 2 standard deviations, it's 97.7. So if you score an 88, you score an 88 on this test, it means that you are in the 97.7 percentile. You're about 98% in the 98 percentile. And if you scored a 92, that goes from 0 all the way, so you're adding all of these up. If you scored a 92, you're in the 99.9th percentile. This means you did better than 99.9% of your students, of the other students. I hope this adds a little bit of clarity to the bell curve. It's not super hard, but it is a little confusing at first. And it sounds like I'm needed to go upstairs at this point in time, so I'm going to end there. Enjoy.